So good morning and good afternoon, everyone. I hope that you can all hear me and that you can see my screen. My name is Dennis Withrich. I'm the CEO of Farallon Geographics, and my goal for the next few minutes is to give you a high-level summary of the work that we're doing in conjunction with the Getty Conservation Institute to develop software to support the kind of data and information management and information access that conservation scientists require. So with that, I'll just dive right into it. We're working on a project that we call DISCO, which is somewhat of an unfortunate acronym if you're like me, someone who prefers punk music to disco music. But it's an acronym that has its foundation in real world, a set of real world, set of real world initiatives. We're trying to build software that will help data conservation scientists build data sets that allow them to do a better job of managing the information necessary to protect and preserve art objects. We've been working on this project for quite a long time, and in the interest of time, I'm just going to jump to the spoiler alert and really focus in on what we're going to be working on for DISCO. So I'm trying to spare you a lot of the backstory. However, if you're interested in how we got to the decisions we made about implementing DISCO, I'm be quite happy to answer your questions either online here or afterwards if you want to approach me directly. So really, DISCO is fundamentally a software platform aimed at achieving several key goals. And they're really listed here at the bottom of the application's login screen. We have really sort of three major things we're trying to accomplish. The ability to manage conservation information in a much more systematic and shareable way. We're aiming to support search and discovery of that conservation information and to ensure that it is interoperable and that it survives the software used to create it. And finally, we want to make sure that the information collected as part of a conservation scientist's daily work actually is useful and usable. That is to say, it supports decisions and on the conservation of an object, as well as research objectives. So these are really kind of the three main things I want to focus on before I hand off the conversation to Rob Sanderson, who'll talk in a bit more detail about how we do this. So let's start with managing conservation information. And in particular, what do we mean by this? And for our purposes, we started DISCO by really reaching out to many members of the conservation science community. We made an effort to really visit and engage many members of the conservation science community. So people who work on a daily basis with conservation science goals, representing many institutions, some large and some small. And what we've very quickly learned were that there were several common hurdles to managing conservation data. And fundamentally, they boil down to a couple key things. The first is conservation scientists are really concerned with a broad variety of data. All the things that you typically imagine. So interest in objects themselves, keeping track of the objects that they're working on and the activities that they're working on with those objects. So those activities might be sampling activities, they might be actual conservation activities, but fundamentally conservation scientists the world over are concerned about very similar things, and they face similar challenges. That is to say, managing the breadth and complexity of these data sets is really quite challenging. And the state of the practice seems to be that individuals all end up having their own sort of homegrown way of keeping track of the information they collect in the course of their daily activities. And that's a problem. Thanasis made, I think, a great point at the beginning of this conversation when he said that people typically end up doing one-offs. And the problem with that is not only is it difficult to share, but it's actually difficult even if you're a professional and working in the same institution. It's often the case that you would have a difficult, perhaps even impossible task of finding information that one of your colleagues is working on because of the unique way in which people organize their information. So one of the key goals of DISCO was to address this problem and build out a software application that allows people to flexibly define the information they want to manage, including the use of thesauri, which allows for consistency and improves searchability, and in a way that structures the data in a linked open data way so that the data are interoperable and useful beyond just a single individual. This plays directly into information discovery. So DISCO's main goal is to allow institutions to flexibly define the content of their conservation data sets and to take advantage of all of the power of that linked open data offers, as well as ensuring that those data are easily discoverable. And what do I mean by that? I mean that the point of filling a database with information is to ensure that you can quickly access the information necessary to support your conservation and research agenda. So for example, one of the key use cases we've seen in talking with the community is that a number of people in the art history world are interested in conservation data and specifically are looking for information that helps them resolve or support some of their research goals. So an example might be, as I've got on screen here, a researcher who's interested in finding information about a suite of objects from a particular location within a particular time frame that have iconographic and laboratory results, all as part of the query string. This is one of the key search and discovery aspects of DISCO that we're trying to support. Once you've discovered information, it's another question about accessing the information. And in DISCO, we have a concept of allowing people with appropriate privileges to access really quite granular information, including digital information from digital data sets. So one of the key things in DISCO is keeping track of not only the work done on an object, but really very specific things, like looking at the results of a sample obtained from an image, run through a laboratory instrument like a GCMS, and seeing the output of that instrument as a series of digital files and incorporating that into the data set, incorporating that into the DISCO software platform, so that that information, that digital information created as part of the daily work of a conservator is preserved, is searchable, and then is accessible so that you can actually look in real time. You can request in real time a digital data set and look at, say, a spectrum to confirm that the spectrum actually shows what your interpretation is. That is to say, if you're looking for azurite, it's often really nice to be able to see a spectrum that shows the appropriate peaks so that you can confirm that the interpretation made by a conservator, either someone within your own organization or in another organization, is consistent with your own interpretations. How do we do all this? We fundamentally rely on a software platform called Arches. And Arches is, it's quite a sophisticated and, to my mind, a really phenomenal piece of software that is, that takes advantage of all the concepts of linked open data. And in fact, Arches allows you to interactively develop models of objects, activities, people, events, or really anything that you think of as important to track in your cultural heritage or object management, information management system, in a way that is completely consistent with linked open data. That is to say, the models that Arches support inherently include ontologies such as the CRM that allow you to define these URIs that Thanasis spoke of at the very beginning of the conversation. Arches also encodes the information in a way that makes it RDF compliant, or essentially the format of linked open data. And finally, it includes built-in thesaurus management software so that you can manage the control vocabularies and preserve the URIs necessary to ensure that you're not losing the connection between the terms that you use and the actual URIs of thesaurus members. Essentially, the key point I'm trying to make here is that Arches is, at its very core, a linked open data information management platform. And we use this as the basis for Disco. So Disco really is an implementation of Arches. And why do we do this? Fundamentally, the goal for us is ensuring that the information that you manage is available and shareable and interoperable, and that it will survive the use of the software that you use to create it. Arches, and therefore Disco, is open source. And I don't have time to go into all the reasons why this is a good thing, but in my opinion, developing software like the software you need to manage conservation data is really well supported with an open source approach. And I would invite you, if you'd like to explore this idea in more detail, to engage with me in a conversation. I want to finish by really pointing out that this work wouldn't have happened, really couldn't have happened, without the Getty taking a lead role in defining the goals of Arches and Disco, and working, certainly in the early days, in conjunction with World Monuments Fund to develop the Arches software that allows us to create really purpose-built information management systems like we're talking about for conservators, that is to say, Disco. With that, I'm gonna stop and really ask Rob to pick up the baton and talk in a bit more detail about the ways in which Arches really does take advantage of linked open data. So, Rob, would you like to take on?